Greetings to all those who are watching this video. My name is Kenyan Lee. Today I'm doing a presentation on the study on deep learning, applications and research trends of deep learning. So this is actually a requirement for the paper submission of GCMT 2020. So this paper is co-authored by me, Dr. Naushad Kadabacha, and also Mr. Syed Muhammad Sulaiman. So I've also attached our corresponding emails. Let's say if you have any questions, you can email to us. So these are outline of my presentation. I will of course first do a simple introduction of deep learning, and also today I'll be focusing on three areas of the use case of deep learning, which are the healthcare, information engineering, and sustainable development. Also I will end with a conclusion. So moving on, introduction of the deep learning. Actually, deep learning, to put it in simple terms, it is considered under a type of machine learning where we use the machine to generate insights so that the machine can produce human tasks for us. So it's called deep learning because it has when we have more than few layers, where I call it deep learning, where you can see here it has 1 layer, 2 layers, and 3 layers, and this blue dot here, blue circle actually is we call it nodes or neutron. So actually artificial intelligence the search journey has begun in the 1950s, started by the famous Alan Turing, where he introduces a Turing test, a test to challenge whether a machine can think. And also throughout the years, like the 60s, like the 70s, where we have Japan doing a lot of robotics. In the 80s, in the 90s, we have the Deep Blue. In the 90s, Apple launches Siri. And so the question is, after that, in our current session, the 2010s, the 2020s, the focus actually hinges on the deep learning as the potential algorithm used as the backbone to build various artificial intelligence tasks that we know of today, like the smart home, like virtual assistant Siri, like maybe VR and stuff like that. So a simple explanation of deep learning theory, expanding on what I've explained just now. Let's say today I want to have a camera that can auto detect how many cars actually pass by on highway. So of course the first task that it needs to be able to achieve is it needs to know what is a car, classify whether the image that it has captured. Let's take for example here, this is an image that I've captured, whether this, when I input into the model, it have to classify whether it is a car or it is not a car. So of course in this case, let's say the model is good, let's say the AI is good, it will be able to say that, oh, the image is a car. So why deep learning now? Why not 10 years back, 20 years back? There are three factors of this. One is the processing power. As you can see here, it has increased 10,000 times since the year 2000. The blue line here. Second and the third actually is interrelated. The second is the storage cost. As you can see from here, 12 USD per GB, it becomes 0.004 per GB dollar. So you see the decrease actually is a lot, and also we have an exponential data growth since 2010. So all these three factors, they contribute to the deep learning. Why we have the deep learning now. So moving on, of course we are aware that there are various fields that are potential for deep learning usage, but today we will just be focusing on healthcare, information engineering, and also sustainable development. So the first one, deep learning in healthcare. So healthcare, one very important aspect is the drug development. So in order to a simple explanation, in order to develop drug, we need to be able to predict the protein, because in essence our body, our cells is actually made out of protein. So in order to tackle, let's say I have a disease, I want to cure the disease through medicine. Medicine actually by itself, it is a kind of substance that acts on the protein itself, so that in a way we can modify or manipulate the protein to get rid of the disease. Of course, there's a layman's explanation. Okay, so take it with a pinch of salt. So let's say today, because the protein appears at a microscopic level that we cannot see it, so we have to predict the structure of it. So by understanding the structure, we are able to affect, control, and modify it through hypothesis testings of different kinds of drugs. So yeah, deep learning is powerful because it is able to make a very a better performance in terms of accuracy compared to other traditional machine learning. Of course, there's a recurring theme in the other use case also, because all of this that I mentioned, the application of deep learning in it, sorry, the application of machine learning in it is actually nothing new. It's just that the algorithm itself has changed. For example, let's say last time we used to use a support vector machine, but now with the use of deep learning, the performance actually improves and becomes better. So another use case is medical imaging. So this is a photo of a MRI. So in here actually, with our bare eyes, it's quite difficult for us to detect whether it has which of these has a tumor. But a computer is able to detect it using object segmentation technique. As you can see here, actually the red part here is a tumor. So the application could be used to flag large artery occlusions and detect tumor regions. So as mentioned just now, bioinformatics, when using deep learning or a machine learning model, we are able to model molecular phenotypes and DNA sequences at a better accurate prediction rate. So moving on, for information engineering, natural language processing actually is a form of a branch in computer science where we allow the machine to understand what is sound or what we say to them, or in the form of text. So as you can see, the usage include a machine translation, maybe from a Mandarin to English, question answering, dialogue system is the famous the now chatbot. Okay, which autos, if you have noticed, have recently the accuracy actually have improved compared to maybe 10 years, 20 years ago, because the underlying fundamental architecture algorithm that they use, deep learning now has actually contributed to the accuracy and also the efficiency. So visual data processing, human activity recognition, now is currently in the trend because of COVID. So as you can see, it can accurately draw a bounding box and also detect that, oh, this person is walking. So this is a use case. Also remote sensing, where this is a satellite photo. Through it, the machine actually can draw a boxes of where the houses is. Okay, so recommender system is something we come across every day. Every day we go to YouTube, we go to Google Play, we go to maybe Yahoo News, we get the recommendation. So this recommendation has to be specific, has to be useful to the user, only that the user will continue. So the underlying architecture that currently in practice is actually deep learning, and also of course a lot of researchers be conducted to improve the accuracy too. So moving on is a deep learning in sustainable development. So this will be a brief one. Let's say agriculture is quite simple. Let's say today I can use my phone to detect plant disease, okay, or maybe automated detection. If the plant has a disease, okay, maybe I will ask my worker to go out and treat the plant accordingly. So other use cases include leaf classification, crop type, weed detection, like segmentation. So precipitation prediction is also important in terms of drought, okay, dry spell, and also the flood. Okay, so deep learning is able to be used to accurately predict this precipitation rate. And also lastly, also it helps in a smart city, like it is able to better predict the passenger numbers. Okay, and also like now currently in research, also power line inspection, as you can see in this photo here, a lot of bounding boxes which are quite very, as you can see here, very accurately label all the model. So let's say this model is have an issue, the algorithm also will be able to detect it. So conclusion, okay, the accuracy has improved. So there are a lot of use cases, and there are 3 research teams One, we need a better unsupervised learning model. Okay, translation learning capability, because we because of building a deep learning model, actually it needs a lot of time and resources. Okay, so it's good if, let's say today I build one model for one task, it can also be used as a branch, as a base to perform another task. So it will be good. And also multimodal data, develop model that can learn from multimodal data, meaning it can, rather than just maybe take in images, it can take in both images and also maybe a text, okay, and process this and give us the desired output. So these are the three future research teams in terms of deep learning application. So of course, this marks the end of my presentation, but due to time restriction, I cannot cover everything. So if, let's say, you are interested in to know more, please go and find out and read about our journal, our paper in the GCMT 2020. Thank you very much and have a nice day.